Welcome developers. This video I will teach about SQL and doing recursive SQL queries and window functions. So these are a couple techniques that are a little bit more advanced than what you would get from most SQL crash course type videos. So I'm going to get into how you can build out rows of information and to make these SQL queries more dynamic. So once you get more comfortable with it, you could do better in like interview style questions or come up with creative solutions that you need. So what we'll do is, first thing we'll do is we'll create a couple tables in Postgres that will have a relationship to each other, and in the end we'll generate a query that looks like this I have here. Right, so we're going to have a couple tables. This pertains to exercising, right? So the idea is people exercise, right? And you could exercise such as you could run 10K, you could do push-ups, you can walk, you can do heavy lifting. And you'll do it on a certain day. The constraint is that there's unique exercises done on each day. And so with each day that you do an exercise, the difficulty of it goes down, right? So when you run 10K, you start at a difficulty of 10. The next time you do it, goes down to 9. Push-ups, it starts at a difficulty of 5. And then it gets down to a difficulty of 1. And then after 1, your difficulty is 0. That's like you've mastered it. Same thing for other exercises. So let's bring in a couple create table statements and insert intos. This is going to take a second. I'm going to copy and paste this stuff here just to create these two tables. Okay, here's the two tables we just created. I'm using dbeaver, by the way. You could download this. It's free database viewer software. Okay, so this is our exercise table. We have 4 different types of exercising. And then we have our exercise tasks. So these are like when exercises are done. So these are dates, and these are the IDs, and there's a foreign key reference, right? So we look at our exercise task, right? Right. This is the foreign key here. The exercise ID column references the exercise table on ID. So this column here references this column. So I hope you get some sort of idea as to what's going on here. Now this is where we're going to introduce the CTEs. Now, as you may or may not know, like CTE could stand for Common Table Expression, right? So with SQL, we can make these queries, a query such as, select star from such and such, where ID equals 5, right? 4, 4. Right, so these are SQL queries, right, where we select certain things. And a common table expression is like a SQL query that will become available for all other like queries, right? So we can interact with all kinds of queries in order to build out large queries. So in order to make a recursive query, you have to start with this thing called a recursive keyword. So this is how you would begin to make a recursive query. With recursive CTE as, right? So that's like, you could call this like a template for a recursive query. And a normal like common table expression is this. Okay. And by the way, you can do this with animal as. Okay, so CTE is just an alias. People often use the word CTE, but you could call it animal. You can call your common table expression animal. You could call it dog, cat, whatever you want. But I'm going to use CTE for today. And we're going to do a recursive one, right? So this is tricky. Generally with recursive, you're doing unions. So you're making a top level query, and then you're unioning the rest of what you want. And there's a condition where what we're going to do is we're going to decrement a value, and then you're going to make an exit strategy because a recursive query could run forever if you don't give it like a condition where you want it to stop. So if we go back to this exercise table I just made, right? So where are we going to stop this recursive query? Okay, so we have run 10k, it starts with a difficulty of 10, right? Push-ups, difficulty of 5. So what we're going to do is we're going to build out a table where we have run 10k, where the difficulty starts at 10, then it goes to 9, 8, 7, 6, 5, 4, 3, 2, 1. Then we're going to have push-ups, difficulty 5, 5, 4, 3, 2, 1. Walking, same thing, heavy lifting, 10, okay? So that's going to be the first thing, is we're going to build out a table where the difficulty decrements downward for each type of exercise. So to start that, we'll do select ID, name, difficulty, from exercise. And we're going to union, right? SQL is not crazy about where you end your lines and stuff. So when you break to a new line, it's similar to making just a white space. Select ID, name, difficulty. And right, we're going to decrement down. We're going to start at 10 and we're going to decrement down to 1, right? So we're going to just do difficulty minus 1 as difficulty. From, and this is why it's recursive, we're going to call it self. Where difficulty, this is the condition where we prevent this from running forever. Where condition is greater than 1, right? Or our difficulty is greater than 1. So if we didn't exit this, our difficulty would start at like 10 or 5 and it would go to negative 10 million or something. But we're going to stop this when it reaches 1. And we do select star from CTE. Let's see what this does. And I already have an error. This is our result, right? Now this is pretty messy. This is tough to look at, right? So we can always order things, right? Order by ID, and then let's do difficulty descending. Okay, so our first ID is run 10k, starts at a difficulty of 10, then it'll go down to 9, 8, 7, 6, 5, 4, 3, 2, 1. Same things with push-ups. Starts at 5, goes down to 1. Then heavy lifting is also difficult, starts at 10, goes all the way down to 1, right? So let's bring back our exercise tasks, right? So these are our exercise tasks. Now what we want is we want to take like this exercise ID, right, which would be running. And you can see here visually that we only did it a couple times, right, on a couple different dates. And so what we want to see is we want to see the difficulty go from 10 to 9. Then on the next exercise, 10 to 9. Or I'm sorry, the next one is going to be like 5 to 4. So yeah, we're going to go about creating this table here that looks like this, where our difficulty decrements down. So for that, what I did was I decided to make a window function where we're going to create rows where we're going to create rows where we're going to build out rows for each of these, and we're going to join them, and we're only going to query where the rows generated, where the row values, where the row numbers generated line up. It'll make more sense in a second. Okay, so what we're going to do is delete this. It's not going to be helpful for now. We're going to select ID, name, difficulty, done on, from, this is a subquery, select star, row number, this is a window function, over, partition, by ID, order by difficulty, descending. We're going to alias this, call this just R. Nope, not radians. From CTE. And since it's a subquery, you have to alias it, so we'll just call it C. Okay, so what if we just did this? What if we just isolated this by itself, right? Just ran this. Right. So now we gave row numbers that are inverted from difficulty. 1, 5, and it ends at 5, 1. I promise this will make a little bit of sense. Okay, keep on keeping on. What we're going to do is we're going to join this. Join. We're going to select similar idea, star. Actually, am I going to do star? Yeah, select star and row number. It's a window function, so you gotta parentheses over partition. This is our foreign key. Order by done on. Alias this as R as well. From our table called exercise task. We're going to alias this as T. So we're going to join these tables on the IDs matching. Equals C.ID. And T.R equals C.R. Okay. And I don't think this is going to work because it's not going to know exactly which columns. I think this may or may not work. Anyway, let's just be more specific up here. C.name. Okay, let's see what happens when we run this. And I have extra stuff here. Let's run this. So yeah, what we got here is we got, this is correct, so we have run 10K. It goes from difficulty of 10 to 9. Push-ups goes from 5 down to 1. Walking, and then heavy lifting goes down from 10 to 9. So we can see that with each time we do the exercise, the difficulty gets less and less, which makes sense. So this is where we did a join, right? However, what we need to do is, if we go back to our exercise tasks, we'll see that this one here, this exercise here, 2, it exceeds 5, right? So for each exercise past its limit, like 5, it's not really showing up in the results here, right? We want everything past its max to be like 0. So for that, I think I came up with maybe the most efficient way of doing that, although maybe somebody else has a better idea. So what I came up with was a union to do that. So what we're going to do is we're going to union, and we're going to select similar idea, ID, name. We need the same number of columns, same number of types. 0 as difficulty. And done on. From, and it's gonna be like exactly like this. We're gonna do the same idea all over again. Yeah. So we're going to copy this. Okay. But we're going to change up the logic a little bit. So we're not going to join on the row numbers matching each other. It's going to be where one of the row numbers, where the row numbers don't exist on another table. So this will be on, we'll use where t.r not in. Yeah. Select difficulty from CTE where ID equals c.id. Okay. And for our presentation's sake, we're going to order this. Order by ID, difficulty descending. So let me review this, make sure that this looks like it makes sense. I think this mostly makes sense, and I think I'm just going to have to add the C as well here. And that's the result. 5, 4, 3, 2, 1, right? And then when it goes past 1, we just do 0 instead. So we had 5, and then we had 3 overflows. We had 8 total. So yeah, that's how you would do that. And the big thing was this recursive query where we start with the columns that we want. We use the union keyword, and we're doing something dynamic, such as taking this difficulty column, right, and decrementing it down, -1, until we reach a case where it's like 1, right, and this is where it's going to stop. And then from there, what we could do is we can add row numbers. We can attach row numbers to it, right, so then it can help assist us when we join another table, right? And that's where we compare, right? We're looking for equality. And then in our final union, we're still matching on ID, but instead of looking for strict equality, we're looking for a value that is not in a different data set. So I have in the video description a link to the GitHub that has a big collection of all these SQL queries I make. So this would be called the exercise problem SQL. And so yeah, just go to the GitHub, like and subscribe, and happy coding.